Sketch the region enclosed by the given curves, these three curves. Set the integral with respect to y. So there's the answer. How in the world? So one thing I really want to help you be clear on. If it says dy, that's the opposite, right? So that's the opposite of what we're used to. We're used to dx. So solve each equation for x, which I know probably sounds weird, not y. Meaning this equation, well, that one already has y, there's nothing to do, and that equation. Because normally, right? Normally I would take like 2y equals 3 root x. And normally we would get y alone, right? That's the normal thing. That's for a normal one, which would normally be dx. But because they gave us dy, I want you to solve for x instead. That'll be easier. So divide by 3. Get the x alone, not the y. Let's stay with the same color. So root x is 2y over 3. Okay, trying to, and then second power both sides to get rid of that root. And so there it is, x is alone. What's this going to be? 4/9, 4/9 y squared. There it is. So we got x alone, not y. So whatever letter you have here, if you have dx, then solve the equations for y. If you have dy, then solve the equations for x. So that makes sense. You always do the opposite of what you have. Normally, we have had a bunch of them with dx, and we solve all of our equations. We get y alone. But it'll work much better, but be much easier if for dy, you get x alone. So there's the first equation. And what we really need to do then is make a little table and get some points for that one. So I'm going to go, okay, I'm going to make a little XY chart here, XY chart, and I'm going to plug in for Y, not X, because it's dy. Plug in for Y. Normally we plug in on this side, right? But we're going to plug in on this side. So I'm going to put in 0 first. So what does X equal? Remember, X we now know is 4/9 y squared. It says so right here. So if you plug in 0 right there for y, what are you going to get? Well, 0. Okay, when you plug in 1 right there for y, what is x going to be? 4/9. Okay, if you plug in 2 right there for x, you can go to Desmos if you want. 4/9 times 2 squared. So I go to Desmos. 4/9 times 2 squared. 4/9 times 2 squared, and I get 1.77. I'll just say 1.8. And by the way, you could have done this on Desmos too. 4/9, it'd be 0.4444. Okay, plug in 3. Now I'm going to plug in 3 for y. 4/9 times 3 squared. Let's come up here and change it. Times 3 squared. Look at that, 4. Okay. That's enough for now. Let's do the other table now. So let me draw a line of separation. Come over here. Now I'm going to take the other equation, this one, and I'm going to solve for x, not y. So 2y plus 3x is 6. I'm going to get x, so I'm going to jump this over. So 3x is minus 2y plus this. Now this is strange. Everything is reversed. Divided through by 3. We're getting x alone, not y. Minus 2/3 y plus 2. There it is. X is alone. And now we can make an XY table for that one. Okay, again, I'm going to plug in like 0. I'm plugging for y. If I put in 0 for y, what is x going to be? It's just going to be 2, huh? See that? Because that'll just go away and x will just be 2. Okay. Now, what if I plug in like 1 for y? 1. Be minus 2/3 times 1 plus 2. Minus 2/3 times 1 plus 2. Minus 2/3 times 1 plus 2. 1.333. So I'll say 1.3, close enough for graphing. Okay, now plug in a 2 for y. Minus 2/3 times 2 plus 2. Minus 2/3 times 2 plus 2. 0.66 or zero point 0.7. Let's say 0.7. I was plugging in a 2 for y. I got zero point 0.7. Now plug in a 3 for y. That's 3. And you get 0. Okay. Now use those to make a little graph. You really have to graph. That's where this gets kind of, it's not easy. So I'm going to just make a graph here and I'm going to go. Um, I'm going to go up to 3. I'm going to go 0, 1, 2, 1, 2, 3. You can go to 4 if you want. 4. 1, 2, 3, 4. Okay. And let's do this equation first. What do we get? 0, 0. And zero point 0.4 over zero point 0.4 up 1. It's the best I can, sort of right there. Over 1.8 up 2. 2, sort of right there. Over 4, I'm just doing this one now. Over 4 up 3. It's kind of scribbly. Over 4 up 3. So basically the graph goes like this, doesn't it? See that blue one? That's this function right there. Now the other one, 2, 0, 2 of 0. And this one, by the way, this is going to be a straight line, isn't it? Because this right here, which is this equation right here, that's a straight line. X and Y are both the first power, which is always a straight line. This other one's a root, so it has some curve to it. So you know that, right? Anytime X and Y are both first power, you get a straight line. Unless they're multiplied together, X times Y, that'll do something weird. But as long as they're added, subtracted, X and Y to the first power, that's a straight line. Over here, root X, that's going to have curvature to it. So anyway, this is going to be a straight line. So I can just do 2, 0, and 0, 3 and just connect the dots. 2, 0, and 0, 3. Boom, those two. Connect the dots. If you want to see the other ones, I can do it for you. 1.3, here, I could do 1.31. It'll be on that line. 1.31. See, it's about right there. Over 1.3 up 1. See that? And the other one is over 0.7 up 2. See, over 0.7 up 2, it's about right here. And then 0, 3, and 2, 0. So there it is. Okay, now they want one more thing. There's one more equation. And that is the y equals 3. What's y equals 3? That's just a straight line up at y equals 3. And here, I'm going to change the color on this one to be red. And that's the one, that's the curved one. So that's x equals 4/9 y squared right here, right? I got the x one right there. And the yellow one, I'm going to make this actually blue. It doesn't matter the colors, but anyway, these points. And that's this one. So that's x equals, this one is, well, I'm going to put it there. This one is x equals what? Minus 2/3 y plus 2. It's that one. And this is this one. Okay. And then the green one, y equals 3. And what is the area they want, the region they want? They want this region right here because this is the region captured by all three graphs, you see, right? The y equals 3, the blue line, the red line. You might think, well, how do you know it's not down here, Mr. Aaron? Well, that keeps going, right? It's not closed by this. You might say, well, how do you know it's not over here? Because it's got to be all three. So if I just draw this one, and this one, what region is closed? This. This is the only region completely enclosed, closed off, sealed and done, right? It's this region right here, which is the words they said, notice, enclosed by the given curves. You got to read the fine print. So it's this region. They want us to set up an integral to find that area. Well, how do we do it? And they want us to do it dy. Notice dy. So that's up and down. So in other words, I'm going to put rectangles like this. Actually, that's probably pretty good. No, that was not good. Didn't go all the way. Like that. I want rectangles like that, and I want to add up the area of those rectangles, don't I? Now, how do you find the area of one of those rectangles? Well, you find the area, say, of that rectangle right there. dy is the height, huh? dy going up the y, this is the y-axis, the x-axis. dy is the height. That's clear. What is the width? How far is it from there to there? What's the width of each one of those rectangles? Well, it's this point right here, which is the right, minus this point right here, which is the left, isn't it? That's the width of each one of those rectangles. We're stacking those rectangles vertically, dy. So therefore, our integral becomes the integral from the bottom to the top of the width times the height, right? Every time, every rectangle is one side times this, length times width, or height times width. So the area of each of these rectangles, width times height. And what is the width? What is the width? It's the right side minus the left side. That's the width. So we got to say, oh, so it's right minus left. And what is the right side? Well, it's this function. It's this. It's x, the x coordinate. It's the x value there, isn't it? Right? The x value is 4/9 y squared minus, and what's the x value right here? It's this, minus 2/3 y plus 2. See how we have to get what the x tells you the sideways position. How far over is this point? Whatever x equals. X is over. How far over is this point? Whatever x equals on that graph. So the right minus the left is the x value minus the x value. And what's the height? We already said that's dy, right? The height is dy. So there it is. Well, we should technically put parentheses like that. There it is right there. You can distribute. Now, oh, the only thing we got to find the bottom and the top. What's the bottom and the top? Well, that's going to go from here. Can you see it? It's going to go from right here. This is the bottom of the region to the top. Bottom to top of the region, right? This is the region right here. This is the bottom of the region wherever they intersect, and this is the top, which is at 3. That part's easy. It goes up to 3. So we know the top is 3. That's easy. The top is 3. But what's the bottom? Where do they intersect? What's that point of intersection? So they intersect where they're equal, where this equals that. So where minus 2/3 y plus 2 equals 4/9 y squared, right? Where this x value equals that x value. That's where they intersect. So we got to solve that equation. How do we do it? It's kind of a pain. First thing, yeah, this is a hard problem. First thing I would do, I'd get rid of all those fractions. I hate fractions. Let's get them out of there. So I'm going to multiply through by 9. Why? Because that's the common denominator. Meaning I'm looking at 9, I'm looking at 3, and I say, hey, they both go into 9. So use 9. And so cancel, cancel. That was easy. This is 4y squared. Here, 3 goes into 9 3 times. That's minus 6y plus 18. A lot of people mess up with the fractions right there. Did you see that? Let me get this thing out of the way because it's kind of in the way. Put this over here. Y is 3. There we go. So you see what happened here? 3 went into 9 3 times. 3 times 2 times minus 2, I mean, is minus 6y. See that? 3 goes into 9. They're gone. This 3 is left over times the minus 2 is minus 6y. So now it looks better, huh? So now just jump these guys to the other side. Boom. So we get 0 equals 4y squared plus 6y minus 18. Right, the plus, minus 6y jumped over became plus 6y. Plus 18 jumped over became minus 18. Right, you get a 0 on one side. Now you can factor that, or you should probably just do the quad. I'm just going to quad it. So the quadratic formula, it's going to be y. It's going to be, um, as you know, the quadratic formula. A to b plus or minus square root of b squared minus 4ac all over 2a. So this is a, b, c. So that'll become, going down here. So we got what? So negative b, negative 6 plus or minus the square root of b squared, 6 squared minus 4 times a times c all over 2 times a. And so again, that is going to be negative 6 plus or minus. It's going to be, you can just type it into Desmos. How about that? Minus 6 plus minus the square root of 6 squared. Minus 6 plus minus square root of 6 squared. So minus 6 plus, oh, come on. Minus 6 plus square root of 6 squared. And the square root of 6 squared. Minus 4 minus 18. Minus 4 minus 18. Minus 4 times minus 18 all over. Times 4, right? 2 times 4, is that what it is in the bottom? 2 times 4, yeah. So let me just get rid of this. I'll just get some answers here. Type it into quad. There we go. So 1.5. There's one answer, 1.5. This is y equals. How do you know? Because we're solving y here. So this is a y. It's a y equation. This is a y. 1.5, 4. So I did the plus opposite, let's do the minus. Probably get something crazy. Let's see, try the minus. Minus, negative 3. So that's the two places they intersect. So this point clearly isn't negative. It must be 1.5. The bottom must be y is 1.5, so the bottom is 1.5. So there we go. We got it. You can rewrite it if you want. I'll bring it down here maybe. The integral from 1.5 on the bottom to 3 on the top, right? Bottom to top of 4/9 y squared. You can distribute this and you get plus 2/3 y minus 2 dy. So there's the, and we're not gonna go any further and get the actual answer. You've done that many times. You know how to do anti, and plug in the endpoints, but these problems are long enough. We're just gonna do the setup and stop. That would be the integral, which will give you the exact area between these three curves right in there. How do we get it? Well, from the beginning, we saw it was a dy. That reverses everything. So you solve your equations for x, get x alone instead of y. Got to make a table. Why? Because we need the graph. We got to see what this thing looks like. So we got ourselves a graph, found the region in the middle, and then we integrated from the bottom. How? Because we're going up dy, we're going up this way. So bottom to top, we had to find that bottom with the intersection work. We found it's 1.5 of the right side minus the left side. So the right side, 4/9 y squared minus the left side, that gives you the width. The height is dy. There it is. There's the sum, the big S of the width, right, minus left times the height. And let's see the actual graph if you're interested. There's the actual graph, just like we said, there's the y equals 3. There's that curve, there's that line. We just set up the integral to find this area in the middle. And so there we go.